Welcome back, everyone. So this is the Extremely Open Science stream. So the project we've been doing for the last several months is called Sardine, where we are trying to figure out if we can transform one simple observation we had, which is that genomes, or in particular metagenome assembled genomes, MAGs, that come from Oxford Nanopore, have a different error profile than the ones we would get in the Illumina era. Now, this is perhaps very obvious, but one of the types of errors that we see is that we see these broken genes. We see this excess of short genes. And this is because Nanopore is going to give you these errors that are more like, short indels, short deletions, little mistakes like that. They break up the frame, so the coding frame on the gene, and then you get these errors. So we've been working through this through simulation and looking at genomes. We started with sort of a handful of genomes that we were looking at. I was just trying to check whether sometimes I want to see whether the sound is working properly or not, but I don't actually have internet to do this. So I see my sound thing going up and down. I tested it before, so let's just assume that it works well. So we've been looking at this for now several months, and a few weeks ago we arrived at one potential solution, and last week we went from testing that solution in this handful of genomes to trying a broader selection, and we've been doing, and now I'm going to start sharing my screen now. So we've been working with progenomes data. So progenomes being this database of genomes that's been annotated, and it has almost 1 million genomes, but they cluster into 40,000 species. So we decided to get the representative genomes and get a sample of these. So this is what we did last week. Unfortunately, so I decided on the stream, I said, I'm going to take one out of every 100, but it doesn't. So that would lead us to one out of every 100. So that's, just say, because this is in expectation. So if we have 40,000, we would have about 400. Unfortunately, it takes about an hour, more or less, to process each one. And so an hour, more or less, means we need 400 hours, and that would mean it would not have finished. So I narrowed it down, and I did one out of every 800. So that's only 44, and then that ran in a couple of days. So I've actually been trying to think whether I want to bring in a little bit more computational firepower here. So I've always wanted this project to be one that everybody can follow along at home, which means not using the HPC, because otherwise, obviously, I could just if I need to run 400 CPU hours, that's or it's not 400 CPU hours, it's 400 because this is a process that takes 8 threads, but whatever that is, 400 times 8, we're still talking 3,200 CPU hours. That's really not a lot. We could we could get that done very, very fast by just adding a lot of CPUs. I didn't want to do that. I wanted to keep this on my laptop, run everything on my laptop. So for now I'll keep that promise, and then I'll think a little bit about whether to keep that going forward or not. All right. So having said that, today, let's first of all look at the results we got. So I show this. So this is the same code that we've been using to basically load so I'm just going to run it. So I also show the outputs a little bit on on the recap video, and then I also mail them to the mailing list. So you can always check those things there. So if I try to do a recap video now. Because I did it only on Monday, because as I said, the results were taking a long time to run, and so I ended up only having those results on Monday. And then I did, but let's see here. It's running now. You can see it takes a little bit of time, even though. So maybe there's a bit of room to pre-compute some of these results as well. But also I did not show this on the stream. I did this a little bit later, adapting here how we get the files. So we had jug space. This is from the simulate.py file. So let me open that. So here's simulate.py. Oh. Sorry, okay, we need to fix that as well. The fact that this is now creating over 90 figures, that's something let's fix that as well. Even though but here, so whereas before we had this was created just with this just with this sort of a hard-coded list of things that needed to be included. Now we have, right, so first of all, yes, you can see, so we have, first of all, we have too many figures, so we need to, let's deal with that in a second. But also here, so this is the JAG file that pre-computes all of the results. So this, and you can see, so this is JAG status simulate.py. Everything's pre-computed, and it has in this input genomes is where we have the right things, whereas before we used to have this input data, right, as hard-coded. So actually, one thing and then the tag comes from, we have this tag that comes from this. Right, so actually the first thing I wanted to do, it's going to be a bit of a pain. Well, let's do that last actually. So I wanted to incorporate these hard-coded ones into the span genomes function, so right now, so this goes through over all of the representatives and then selects every nth one. But I wanted to special case these ones that special case and have this as a, always included, so that we have them, right? And so let's do that last, because it's going to mess up the it will take a long time to rerun, and so it's going to mess up a little bit the rest of the processing. So let's do that a bit later. Okay. Here in the meanwhile, okay, let's see what we do here. Okay, so we kept the tag, we load the diamond. This all takes, so this is all very fast now. And this takes, okay, we don't need to be, we can move this, because this is only done once, so we can move all of this here to the bottom instead of setting the label every time. And then here, this one, it's nice. We actually should I don't know why I get this effect. No, I mean it's not bad to just look at them actually a little bit. You know, it develops a little bit of intuition for them. So here, yeah, you can see, oh, this one is nice. It would actually been, what we've been trying to capture is this gap between the blue and the green line. The fact is this green line tends to be higher up. But you can see, and you can do this. So this makes this one a little bit less transparent. So in this case, right, this one, the one that's on top, you can see even the blue line is already a little bit elevated. So this is this one. Yeah, so this. I think this one might be the one where we have. Let me just make it semi-transparent. Yes, you can. This one might be the weird one that we see here. This red one, right? That. I just. So what I want to do two things, or I want to do a couple of things today. Mostly to, and I think there's a certain back and forth between looking at, expanding what we're doing, and expanding what we're doing, and consolidating the results. And so this back and forth between expansion and consolidation. So today, so last week was big expansion, maybe not this, maybe still actually there's still a lot of compute to be done. I'll still compute more of these genomes, but today I wanted to do a little bit of consolidation as well. And so one of the things is making sure this code runs a little bit better, so it doesn't generate 90 plots, but maybe pre-compute some of the tables, and then we can plot what we want out of them, and also trying to look at what's happening in this one, in this red line. So one of the things that we actually never check is what does checkm2 say about these, so for example. And the other thing, really even just from a purely computational perspective, is clean. So far we've been using Conda here. And I've been exploring switching to Pixie as a slightly nicer version of Conda, or significantly nicer version. So I'm gonna also try to switch the project over to using Pixie. I think it would solve a few problems, and it will just be nicer. But also one of the objectives of this is that I force myself to try, all of these whatever new technologies, including, I've been playing around with polars here, whereas before I was much more comfortable with pandas, and I'm very familiar with Conda, and now I'm going to force myself to learn Pixie, because it does seem to be a nicer version. All right. Okay, having said all of this, all right, so let's first try to see, can we do this quicker? Okay, so we have So I want to move this. So I want to save all of these z-scores. Yes. So instead of instead of plotting the z-scores, let's do something like this. Okay, this would already make it slightly faster, so this would avoid this. Actually, I wanna see which one that is. What's that? Okay, this is. Okay, let's remove that. If I did this like this. I wanna still look at this red one a little bit more. So this is so these are the two things we want to do today. Look at this red one a little bit more, develop a little bit of intuition. So we've cleaned up the code at least so that when we can run it in a way that's doesn't generate too many okay. Yeah, this is the new, okay, same as before. Sure, do it. Okay, so this I had seen this actually before. So that this, I had seen this. Well, I had sort of picked it out by looking at the color here, which is a bit awkward. but you know, this is the right way of doing it. So this is the right thing to here, and nope. Wait, how did I get this? No, this was. Yeah, so if I get this 28903 is Mycoplasmopsis bovis. So this might be just a weird bug, although, you know, it does. So one of the things we actually don't check we never actually checked what we didn't check what Diamond, not Diamond, what CheckM2 was saying about this. So if you load this table, it's a 65% complete genome. So actually it does seem that that CheckM2 also doesn't think this is a great genome, and CheckM2 very quickly calls it a very degraded genome. So there's some graded genome, translation table form, you know, that's not contig and 50, so this is, but the average gene length 153, so these are very short genes, generally speaking. So everything seems very short here. Not sure what this is telling us. I think this is telling us that this is a strange organism. Alright. Might as well, let's look at the second one. What's the second one? No? Okay, maybe this doesn't exist. Okay, I don't know what this is. Let's try again. No, this is a different thing. What is it? Brocholderia, okay. Also maybe some, okay, so some okay, not sure what I feel about all of this, but let me look just at that one. I do want to look at it. This one. No, wait. Wait, sorry. Sorry, my... This back in. Sorry, my bad. This is... You think it would be the same, but... Okay, actually it's surprising. Wait. If I look at all these scores, let's compute let's compute all these scores, or Z scores, I guess. Still want to do this. Okay, alright, so because this could also be a metric, just the average Z score, but it seems that if I look at, yeah, that is an outlier, that one, that, interesting. It has these very, very large outliers in the positive sense as well. So these are massive genes. Oh, actually, no. So, wait, what? Sorry, I kind of deserve that. I don't know why I'm being slow with this today. Yes. Okay, this is yeah, so this is the one that's weird. Yeah, it starts out looking like a bad genome. Doesn't really improve. Maybe there's something more interesting going on here. Actually, what I want to do, I want to table this for a bit, because it would still be so we did 44 genomes and we found this one that really behaves strangely. Maybe we just got lucky or unlucky that this is really 1 in 1,000 and we just got lucky with our 44. Or if it's 1 out of every 40 or 1 out of every 20, then it's a bit more problematic. So, if we can't have a metric that fails in 5% of the cases this badly. But we could have a metric that, if weird genomes with maybe it's guessing the coding table wrong or something like that. And that's going to be everything downstream of this would be messed up. So that would be okay if it's like an edge case. So I actually would like to look at to have the results from more computation before making decisions there. Right, so I'm gonna clean up here. So keep some of this that we had, keep it, because so this keep it maybe at some point. Just double check that this actually runs as it should. And now I want to do the other thing. I want to do something else which is also kind of fun and very different, which is switching this project over to Pixie. So just double check. Okay, so that seems everything seems to run there. So Pixie is, I'm not 100% sure what's the what's the underlying organization behind Pixie, but Pixie, and I think I'm also going to post it in the chat. Pixie does Pixie is basically a much a more modern version of it in many ways. So oh, this is still running. So sorry, I shouldn't. I thought I had okay. So let's see what. Okay. Yeah. Okay. So you do need to install it. I'll post some. Let's actually work. But then you get a bunch of stuff like this. So let's do this pixie init. Okay. And now, okay. So the way that pixie works is that, you know, and again, I'm still trying to figure out how pixie works. So we're all trying to figure out how pixie works. So but I think the important thing is we have this file called pixie.2ml. Oh, okay. Let's figure that out a bit later, actually. Okay, this is actually a good point. Actually, these are related. Okay, so there's some Polars versioning things here going on, which I actually don't like either. So, because depending on which version of Polars is running this code, actually I had run into this also last week, but let's fix all of this with Pixie. Pretest. Or avoid otherwise. All right. And so we can use this command line pixie add, and so pixie is based on the same as Conda, and so it uses the same packages. So we can, I think it's except, so I think it uses this more modern approach where you have a file, and that file, so when you add things to the command line, so when you add these commands like add, what it actually does, it's going to add things to that file, and then, oops, sorry, it's going to add things to that file, and then see, yep. Right, and then also it creates this other file, pixie lock, and now I think let's and now I think I can do this. Yeah. Okay, and now I'm inside a. So now so this is basically like doing conda activate. Except, first of all, it's slightly faster, 1, 2, 3, okay, slightly faster than conda, but also because I believe that if you run it based on this exact pixel.lock and pixel.2ml file, you will get exactly the same result. Okay, and then we used to have this problem where we needed a separate checkm2 environment. I'm gonna see if this works. Okay. So checkm2 does not work. Because it requires this very, very particular version of NumPy. So I think what we need to do is create a second environment. Pixie. So this, I've been playing around with this a little bit for testing. And so I think we can have a second. So I think we create a feature. Let's do let's. So I think you could do all of this with Conda, but it was really not the natural way of doing it. The natural way of doing, because you would have to jump through multiple hoops to get this reproducibility. No. Multi-environment, yes. Yeah, this is what we want. We want something. Remove that. Let's do this. Checkm. We want to have a checkm2 feature with checkm2. Okay. And we want to have an environment checkm2. Okay. All right. Okay. What if I think maybe this is what we want to do. we do it? Okay, so now we have two environments. Then we don't even have a default environment. We just have the sardine environment, and then we have the. Okay, that works. And then we have the checkm environment, checkm2 environment. So the good thing about Pixie is that this is taking a little bit of time because it's downloading all of this, but it will only really do that once, and then the next time it will all be in cache or cache. Actually, I've heard people agree on how you should pronounce this. Okay, and there it is. Okay, very good. This is, yep, just wanted to see, does this still works when I'm running it from, very nice. And oh, yep, so it still runs there. But instead of conda run, I'm going to now write pixie run, and then this should work exactly the same as before. Just to be 100% sure. So okay, here I'm a little bit cheating because so as I said, I run it every 800th, but I've also been running it every 200th, and that is not finished. So if I do the status, you can see it's not finished. So let me just try executing it. See what's happening. So yeah, there are jugs running. And then if everything works okay, within a little bit, it will start running checkm2. So now it takes a little bit to generate all of the mutated versions. There it is. And now I think it's running checkm2. And oops, it didn't run. Oh. Okay, and it does not run checkm2 because it does not find it. So it should find it here. Why does it not find it there? Let's debug this. Let's debug this a little bit, and then let's all right, let's do this. Okay, this is Okay, so this again should okay. Okay, sorry, messed it up. Okay, takes. If I do this, what does it do? Okay, I don't want to do this because this is going to take several hours. Or maybe not several hours, but still, I still want to do it. Well, maybe it's okay. Maybe it's going fast now. In the meanwhile, we can. So last week I did have a bit of a hard deadline because I was trying to finish just as and I had something immediately afterwards, and I rushed the end of the stream not to go overtime. You know, a little bit less problematic today. I don't, but still. Let's see. We can. Okay, so this pixie log file, we don't want to be even looking at it, but this pixie, well, so I've defined two environments. One is the checkm2 environment, the other one is the sardine environment. No, actually, could this work? Instead of doing this, could this work? So the very nice thing about Pixie and the fact that it's based on these files, as opposed to Conda, that's where you add things on the command line and it does magical things underneath, is that if you revert back the file to what it was before, you will get what you had before. You know, there's no weird hidden state. If I do this, this work? Okay, I was trying to see if we could, if this would override it, right? If having numpy there, if it would override the dependencies, but I guess not. So I'm gonna okay, I'm still not sure that this is the best way of doing this, but so in the meanwhile, check M2 did. So if oh. Okay, sorry, did I mess this up? Yeah. No, I think I messed this up a bit now. Okay, sorry, I don't, not the log file. Okay, so we have checkm2 in a environment and separate sardine environment. Okay, so I don't understand how this works, because this was always there. Okay. Okay, so maybe this is a problem with so before we were running a different version of checkm, so there could be, maybe we just need to go back to that one. A bit annoying. Okay, we're updating the nodes. Alright, this is not working for me. What if we do okay. Is checkm2 okay? All right, so this is a recent version of checkm2, so maybe there's a problem here that Alex needs to fix. But in the meanwhile, okay, okay. In the meanwhile, using the previous version works. Okay. or does it? Okay, yeah, okay. Right, let's download the database yet once again. Oh, actually, I messed this up. This should be. So this is the version that was for 1.0.2. Do this. Okay, let's do this. Nope. Nope. Okay, this is also why we use Git, is to, we added all of this, debug code, and now we remove it. And, we were playing around with all of this, but in the end, we only keep, these small changes there. I do wanna see if this runs, because it's becoming. So if it is a matter of checkm2, the latest version failing, then I'll also let Alex know. But we would have updated to Pixie. Then we just investigated, browsed some. And here, I still want the let's check. I said that I wanted this week we could go a bit over time, but this is now becoming a bit too much over time. So let's just wrap this up. I do want to add the simulated, not the simulated. I do want to add these, special case popular ones into an allow list, and then just change the code very quickly. Okay. Yes, okay. This works. This works with a terrible. Okay, this works. So there's some. Okay, now we have, and the final thing we need to do is to make the I don't know why I was doing that. So this input data, so let's call them special microbes, and expand genomes takes in the special microbes. The special microbes, let's see. Yeah, it's the other way around that I want. Okay, I think this is what I wanted. So I wanted two things. So first of all, I wanted to add this. I wanted to special case these. So these special genomes or these special microbes, they will always make it into the list. And second, we should, instead of returning just the like this, it should, instead of doing this ugly manipulation, it should be like this. Yeah, and they also get nicer name tags. Okay, and this will take a long time to run, so I am not going to do that on stream. But let's okay, this was a very long stream today. Let's just wrap up. You know, and then here when or ifile tag. Oof. Okay, we did well. I unintentionally committed this idiocy there. So let's see if now, if this runs. There's still an issue there with a known issue with the exact version of polars, and we will fix that next week. Now that we have a little bit more control over what versions of polars are running. So okay, so this also just relook. This seems pretty reasonable. We should eventually do all of these things. Oh. Okay, this is also interesting. Okay, let's fix. We'll need to fix that a bit later. Let's do that next time. So the problem, there's an underlying problem, which is when I use NeoVim, I'm actually not using the same exact version of Python. I'm using a slightly different environment, and this keeps causing this type of issues. And I think ideally I would be able to use the same version of Python, and I think I would be able to do that fairly easy with Pixie by just adding the right things to the environment. But that will be for next time. So in the meanwhile, let's push everything into Git. So everything's on Git, so you can see. Yep, there. Everything's on Git, you can see it there. And so I'll also be posting on the mailing list. So as usual, so the long running processes, I will leave them running for the next several days. We will have results, and I will post those on the mailing list. So let's wrap up for now. I will, subscribe to the mailing list, show up on Discord, subscribe to the